So what I was thinking now, we'll have our new chapter. And then we'll do a tutorial. If you look at page 66, please. What? Have you got 66? Yeah. What you doing, Pony? Not yet, not yet. Because I'm going to tell you something important. Page 66, I do this, but it's not on the exam. So what I'm thinking is we can skip page 66. I put this page in here, but I feel like I would rather skip this page because it's not on the exam or the syllabus. I just put it in as an extra. But I think to save a little bit of time, to give us more revision time at the end of the semester, we'll skip over 66. If you want to do 66, go ahead. You can watch the video on the YouTube channel. You can type in the name of the lesson, and you can watch the video from last year if you like. But it's optional, so we won't do it. You might want to write that on the top for when you're doing your revision. So this one here is not on the course, on the exam, okay? Yeah, but this is the thing, the method here is not on the course. So we will still do slopes and derivatives like you're saying, but the method I teach in this lesson is not on the course. Yeah, that's what I'm saying. So we don't have to worry about this lesson. Okay, so can we turn then to 68, please? So we're in a new chapter, Differentiation, and the lesson now is called First Principles. Yeah. Okay, and differentiation is actually part of a larger topic in maths, which I think some of you know the name of. Does anyone know the name? Somebody knows it. This chapter, differentiation. Nobody said anything. You're just sitting there looking at a black screen. Something wrong with you. Okay. Differentiation. First principles is the lesson. Differentiation is part of a larger chapter in maths. Does anyone know its name? Calculus, yeah. So calculus, part of calculus is differentiation, and part of differentiation is this first principles, which is actually a method we're going to have a look at now. Okay, so just write those names down, please. Yeah, got that? Yeah. Okay, can I scroll down? So let's return to something familiar. So imagine here I have this quadratic, and here I have this line here that goes through the quadratic, and it meets at 2 points here. Could we find the equation of this line? We could, if we knew these points. Yeah. Now what happens if I draw the line and it only meets, it only meets once? can I find the equation of this line now? Not really, because I only have 1 point. And you know from your formula you need to have exactly 2 points to get the slope. Yeah. So this is an interesting problem. By the way, the name of this line, it's a special line. It has a special name. Does anyone know? Yeah, it's a tangent line. The line which cuts twice. Does anyone know the name of this line? Very, very good. You read the last page. Yes. Secant. And you translate it. Oh, good. Okay. So we are interested in tangent lines. Okay. Now, let's go down a little bit to try. Sorry. In this lesson, we're interested in finding the slope of the tangent line. So that's what we're going to look at today. The slope of the tangent line. Now, there's actually, let's just imagine I call this point here x. It's the slope of the tangent line at x. This actually has a special name as well. We don't say slope of the tangent line at x. Instead, we say the derivative at x. So you see this word here, derivative. That means slope of the tangent line. Means derivative. So if I ask you for the derivative, it's the same as asking you for the slope of the tangent line. It means the same thing. And, yeah. Yeah? Can we go down? Yeah? Okay. So let me show you how to do that using the method called first principles. So we'll use an example like x squared, something simple like y equals x squared. And let's say the x, I'll just draw it here as x. So if I go up to this point here, what is this point here? It is x, and the y value is x squared. Now I cannot find the slope of this line, can I? No, it's impossible, because I only have 1 point. What I could do is I could draw a line that goes through this point and then goes through a point which is really close to the first point. So I know it's not a tangent, it's a secant, but the secant is roughly the same as the tangent. So what I do is I go a little bit to the right and call this point x plus a small number we call delta x. So what would be the value here? It would be x plus delta x. And what would be the y value? X plus delta x squared. Sorry, that's a bit small. Let me write that again. It would be x plus delta x bracket x plus delta x bracket squared, like this. Okay? So, we can use our formula for the slope. M should equal y2 minus y1 over x2 minus x1. So that would be x plus delta x squared minus x squared over x plus delta x minus x, because this one here I'm taking as x1, y1, and this one here I'm taking as x2, y2. Yeah. Got that? Yep. Okay, so let's clean this up. On the top, we will get x squared plus 2x delta x plus delta x squared minus x squared all over delta x. This is equal to 2x delta x plus delta x squared all over delta x. Now what happens here? We get some cancelling. They will cancel with that, and that will cancel as well. So you're left with 2x plus delta x. So I'll explain what that means in a moment, once you write that down. Got that? Yep. So, just to be clear, m here means the slope of the tangent, doesn't it? But here it's not quite the tangent. What is it? It's a secant. It crosses twice. We really want the tangent, don't we? So what we can say here is that the slope of the tangent, that's roughly the slope of the secant. And we call that slope, we give it a special symbol. I call it delta y over delta x. So what I have here is that the slope of the secant, which is the slope, that's equal to 2x plus delta x. So let me show you what that means on a graph. What that means is, if I have a quadratic like this, x squared, and I'm here at the point 4, and I draw a tangent line, the slope of the tangent line is going to be roughly equal to 2x plus delta x, but the x is 4, so it's roughly equal to 8 plus some small number. So, you know, it's roughly equal to, well, the small number is roughly equal to 0. So you could say, if you wanted to, it's roughly equal to 8. It's somewhere around about 8. Yeah. So for this lesson, we're using this method called first principles. So just to give you what might be the formula, if you want to calculate the slope of the tangent by saying it's roughly the slope of the secant, you can say that it's roughly equal to fx plus delta x minus fx over delta x. And the reason is, when you draw your curve, this point here is x fx, and then this point here will be x plus delta x, and its y value will be f of x plus delta x. So on the top you have y2 minus y1, there it is. And then on the bottom, what do you have? Well, that's x2 minus x1. So there's x2 minus x1, and that goes on the bottom. So this is like a formula to get the slope. But usually what happens in the formula is you end up with an answer plus some small number as well. I want to show you with the graphing program exactly what's happening, but you can write this down. So if you want, this is like the first principles formula. Now, we're talking about making the x here, the delta x, a really small number. What do you think happens if the delta x becomes so small it's actually 0? Do we still have a secant? Not really, because if the delta x is so small that it's become 0, instead of having 2 points you only have 1 point, because they both come together. Because
it will be like...
Well, it gets really complicated then, but what I just need you to imagine is if I have the 2 points and I bring this point down here, then it's now only 1 point. So what I'm saying is, in this example, you see we had 8 plus a small number, and that small number was delta x. If I make delta x really small, I can make it actually into a tangent. So when you know the exact answer, we call that dy dx. So dy dx is the secant slope, but you make the delta x go to 0 at the end. So if I ask you for the first derivative, it means I want the exact answer, which means at the end you make the delta x go to 0, so that instead of a secant it becomes a tangent, which is what you care about. Now I want to show you this in the graphing program. Can I go to the graphing program? If I have it open yet. So let's take our example of x squared, and let's draw it. And we were at the point 8, I think. Whoops. 8 is quite far out. Let me shrink this a bit. Right, so there's 8. So I draw the tangent line here. So for example, if I say what do I want? Tangent line at the point x equals 8. No, I have that backwards. Okay. Wait, did I say 8 or 4? Something feels wrong. No, I said 4, and the slope is 8. It was 4 on the x-axis, but because there's a 2x, it was 8. So let me just fix that. It was 4. Okay, so let me draw the tangent line. So you can see there's the tangent line at the point 4. And you can see that it has a slope. But what we did when we had this small delta x, we had a tangent line. It was a little bit different. Let me just.
4 point something?
Yeah, exactly. Like if the delta x was 0.01, that's a small number. We actually drew something more like this. Roughly. So you can't even see the difference, but you can kind of see it here, that if you have an x and a delta x, but the delta x is really small and the 2 points are close together, it's almost the same tangent line. And if you want to be 100% accurate, then you make the delta x 0, and the secant and the tangent become one line. So if I kind of zoom in here, we can kind of see that. Zooming in. No, that's zooming out. Zooming in. Here we go.
Yeah.
Yes, it's like PS4. So you can see the black one. It's hard to see, but it crosses here and it crosses here. And those 2 points are so close together it almost looks like the blue tangent line. I would have to kind of expand it a bit to get more of a difference. Now you can see it a bit better here. Uh-oh, wrong way. Yeah. So you can see that the black line doesn't meet once, it meets twice. But it's nearly the same. So what I'm saying is, you can use this formula, called first principles, to get the secant slope. The secant slope. But then to make it a tangent slope, all you have to do is this step at the end. Make the delta x become 0. Then you have the tangent slope, which is what you want, which is called the derivative. Okay? So what we'll do is, we'll do another example of this method to get the slope of the tangent, okay? And then I'll let you try them for a little bit. So I don't know if you need to write anything down here, but what's really important is this and this. Now just so you know, sometimes people might write this as follows. dy dx, the slope of the tangent equals the slope of the secant, but you make the delta x go to 0. That's what this piece here means. This is not on the course though, so I don't really think they should write this in the exam because it's not on the course. So I'm just going to write it like this. At the end, make delta x go to 0. Then your secant becomes a tangent. Okay, so write these notes down and then we'll have a look at another example. Are you ready for it? No, I see some people writing. Yes, we can do an example. So we did a quadratic. Let's do something a little bit more difficult. Sorry, Malik or Salik. Malik. I'll remember M for maths. It's Malik, isn't it, with an M?
Yeah.
Yes, M for maths, Malik, right. Are you ready for me to do the example?
Yeah.
Yes, Ricky? Yeah? Okay. So let's take something like fx equals 1 over x. The graph you don't need to know for the exam, but if you're wondering, the graph goes downwards like this. So let me pick a point here which I call x. If I draw the tangent line, it should be a negative number, shouldn't it? If the x is on the right, the graph is going down, so the slope should be negative. Okay. Okay. So let's use our first principles formula. Delta y delta x equals fx plus delta x minus fx all over delta x. So here, what would I get first? What would this be? Well, f of x is 1 over x. So f of x plus delta x will be 1 over
X plus
thank you,
delta
x plus delta x minus f of x, which is 1 over
X.
x. And then here is delta x. Now, what I'll do is I will stop for a minute because I would like people to try and simplify this here. So this is your job now. I want you to simplify this. Oh, I'm so popular. I don't like my phone because whenever I get text in it, it usually means I have to do more work. Somebody wants something or somebody is looking for something. Nobody ever sends me a text saying, hey, what's up? How are things? Everybody wants something. Yeah. Because, you know, in Ireland, the exam is also in the summer. So everybody wants extra maths help. Okay. Are we simplifying? Looks like we're having mixed success. Or no success, maybe. No simplifying? Because you can't, or because you're tired, or because you're lazy? No, it doesn't look like you're... Are we not simplifying because we can't simplify, or because we don't feel like simplifying right now? Have you simplified it? Come show me what you did. Where? Are you? Wait, hang on. Good job. Anyone else? Don't cheater. Okay, let's have a look at it. So, firstly, I think the first thing I'll do is I'll put the top together. So on the top, it's okay. We all make mistakes. It's okay. Don't judge him, okay? Right. So on the top here, we have x plus delta x. What I'm doing is I'm making a cross here. Add them together. So here, 1x minus 1x plus delta x. 1 times this minus this times this. Okay? Yeah. Right, so if I multiply the top, I get x minus delta x, and here I get x plus delta x, and here I get delta x. Is that okay so far? Yeah. Now on the top, cancels, and what you can do is multiply by 1 over delta x and multiply by 1 over delta x. And the reason I'm doing that is so I can cancel this with this. So now it's all together on one line, which is better for me. But as something else cancels, what else cancels? This delta x will cancel with this delta x. So now, what I have on the top is just a minus 1. And on the bottom I have x plus delta x, which equals minus 1 over x squared plus x delta x. So I have the slope of the secant is equal to minus 1 over x squared plus x delta x. So what would be the slope of the tangent? Minus 1 over x squared. Get the idea? I keep saying slope, and this is bad of me because slope is what we use in Ireland, but in the UK they have a different word for slope, which I told you. Does anyone remember it? No? Begins with a G. That's it. So in the UK and your exam, because it's a UK exam, they will say gradient, not slope. But I told you this in the first week, but I don't expect you to remember. I keep saying slope, I should be saying gradient. So the gradient of the secant is there, and the gradient of the tangent is that one. Yeah? Okay. For the exam, they usually like to ask x squared and x cubed. But they could have something like this. So you need to be just a little bit careful. The one at the end here, square root x, is the last part of question 1. That's a little bit tricky. So let's have one try. So in question 1, Question 1, ABC, KL. So question 1 is ABC, KL. Now in question 1, I only want the secant, so you don't make the delta x 0 at the end. But in question 2, I do want the derivative, so you must make it 0. I just would like you to try in number 2, D. Okay? Also, try number 3. And 4A. Got that? Alright, so the plan is you can try those for a few minutes, and then after that we'll do a tutorial on the trigonometry stuff we've been doing this week. Okay? So you can try these for a few minutes.
What does mean slash x?
Which one?
dy over dx slash x is 1 minus 3.
Yeah. In 4A, what I mean there is the slope, the gradient, but at the end make x minus 3. The point is minus 3 on the curve. Yeah.
So it's not the
No, it's not. It's not. It's yeah, guys. Can you just look up? Sorry. If I write this, what that means is dy dx, but then at the end, you want it for when x is 3. So when you get the answer, you make x 3 to get the answer for the slope, the gradient. Yeah. So the way I see it, Malik, is I think of this is the same as this. You get what I'm saying?
Yeah.
Yeah? Okay. Alright, try these for a few minutes. Yes. Oh yeah? Looks not, I feel like something is wrong here. I think something went wrong. I think, maybe. I see you got the A and the B, did you? Yeah. And now you're trying to get the K, is it? Um, something went wrong. I don't know. Um, something looks a bit suspicious here. Are the powers like that? You see, I thought the powers should have the same n, the nn. So this should be kn, kn. So here I was expecting these two to be the same, and then these two will be different because you're using a different n. So here, what did you use for n? Is it the 8th term? This is the 3rd term. So then n is 3. So if anything, this should have been a 2 for you. So how'd you get to 8 here? You think you know what's going on? Okay. Okay, Tony?